Hi viewers, welcome to YouTube channel Kang Pag Study Support. Today's topics are conjugate acid-base pair, amphoteric substances, monoprotic acids, polyprotic acids or polybasic acids, common ion effect, solubility, factors affecting solubility, and solubility product. So, without wasting any time, let's begin the class. First of all, let us discuss conjugate acid-base pair. Those pair of substances which are formed from one another by gain or loss of a proton are known as conjugate acid-base pairs. For clear understanding, let us discuss by taking acetic acid as an example. Acetic acid having chemical formula CH3COOH, which when dissolves in water, it dissociates into hydronium ion having chemical formula H3O plus and acetate ion having chemical formula CH3COO negative. Okay, here acetic acid loses a proton to water, so acetic acid is an acid because it loses a proton. On the other hand, water accepts that proton loses by the acetic acid and forms hydronium ion having chemical formula H3O plus. So water is a base because it has the capability to accept a proton released by the acetic acid. Okay. Similarly, hydronium ion having chemical formula H3O plus can donate a proton to the acetate ion to form acetic acid. So hydronium ion is an acid. Why? Because hydronium ion can donate a proton. Again, acetate ion can also a proton released by the hydronium ion. So acetate ion is a base. Why? Because acetate ion can accept a proton released by the hydronium ion. In the above example, acetic acid is an acid, okay? Because it has the capability to release or to produce or to donate a proton. After donating a proton, it forms acetate ion having chemical formula CH3COO negative, which is a base because acetate ion can accept a proton. So, acetic acid and acetate ion are conjugate acid-base pair. Why? Because after losing a proton by acetic acid, it forms a base. So, acetic acid and acetate ion are conjugate acid-base pair. Similarly, water is a base. Okay, because it can accept a proton. After accepting a proton, it forms hydronium ion having chemical formula H3O plus, which is an acid because hydronium ion can donate a proton. So water is a base, hydronium ion is an acid. So water and hydronium ion is also a conjugate acid-base pair. Okay, clear? Next is amphoteric substances. Those substances which can behave as an acid as well as a base under different circumstances are called amphoteric substances. For example, water, aluminum oxide, amino acids, etc. Next is monoprotic acids. Those substances which can donate only one proton in a reaction with a base are called monoprotic acids. For example, hydrochloric acid, hydrogen bromide, nitric acid having chemical formula HNO3, okay, etc. These are all examples of monoprotic acid. Next is polyprotic acids or polybasic acids. Those acids which have capable of giving more than one proton per molecule are called polyprotic acids or polybasic acids. For example, hydrogen sulfide, carbonic acid, oxalic acid, sulfuric acid, etc. are dibasic acids as they can give 2 protons per molecule. Phosphoric acid having chemical formula H3PO4 and arsenic acid having chemical formula H3AsO4 are tribasic acids as they can give 3 protons per molecule. All the above dibasic acids and tribasic acids are example of polyprotic acids or polybasic acids because they can give more than one proton per molecule. Okay. Next is common ion effect. Common ion effect states as the degree of dissociation of a weak acid. It is symbolized by Sa. Okay. Or a base, and it is symbolized by BOS. Okay. Is suppressed when a strong electrolyte containing either common A negative or B positive ion is added to the solution. Let me explain you in Manipuri so that you can understand clearly. Hojik aikona tamdorisi common ion effect haibani. Common ion effect aisna karino haiba matamda. Karigumba weak acid se hojik ice A haidana asida represent tawre aduga base na BOS haidana represent tawre. Weak acid ama natraga base ama water da dissolve tawraga solution sema matamda weak acid tu natraga base tu dissociate ion oina dissociate tawgani masigi ion oina dissociate tawbagi changse masibu degree of dissociation kawi. Weak acid ama natraga base ama na water da dissolve tawraga solution sema matamda weak acid natraga base tu na dissociation tawbagi chang degree of dissociation se handarakani ba karigumba hairiba solution aduda either ko common A negative ade kainai kanda acid tu dagi ice positive proton do lokthokraga lemhogba anion do madu yawba strong electrolyte ama acid tu gi solution da hapsal labde acid tu gi weak acid tu gi degree of dissociation handarakani hadni natragana base ki solution oragana base tu dagi ois lokthokraga lemhogba cation do B positive to madu yawba strong electrolyte ama base tu gi solution da hapsal lagade base tu na dissociate tawbagi sang degree of dissociation si handarakani haibani. Gyan tare ko? Illustration of common ion effect. Okay. Let us consider an example of acetic acid which has chemical formula CH3COOH. Dissociation equilibrium which is represented as acetic acid in aqueous medium dissociates into hydrogen ion and acetate ion. Okay. And maintain equilibrium. Addition of a strong electrolyte containing acetate ion. Okay. To an acetic acid solution results in decreasing the concentration of hydrogen ion means the equilibrium will move toward the backward direction. Equilibrium moves toward the backward direction means dissociation of acetic acid will be suppressed. Okay. Similarly, if hydrogen ion are added from an external source, then the equilibrium moves in the backward direction. That is, dissociation of acetic acid will be suppressed. Okay. Equilibrium moves in the backward direction means toward the undissociated acetic acid, which means that dissociation of acetic acid will be suppressed, will be decreased. Okay. This phenomenon is an example of common ion effect. So, common ion effect is a phenomenon based on the Lee-Salier's principle. Let me explain you in Manipuri also. Hojik common ion effect si illustrate tawduna henna gyan tanaba illustrate tawduna yangsi. Akoi acetic acid se weak acid ni haiba si khange adude weak acid ama natraga base ama lauraga akoi common ion effect si utka dawni aduna masigi ki acid akoi acetic acid hariba weak acid si khanarasi laurasi. Acetic acid sina magi aqueous medium da haidi ising da thitpa solution da aqueous medium da magi ion hydrogen ion haiba maga acetate anion haiba maga anion anisi dissociate tawi anisi da amadi anion anisi ga acetic acid dissociation taw da acetic acid and dissociated by acetic acid siga anisi maintain equilibrium maintain taw dun lay. Hujek acetic acid ki solution du da strong electrolyte acetate ion yaway strong electrolyte amaka hapsan taragadi kari tawrakani haiba matamda acetic acid solution dugi dissociation tawbagi sangse masi suppress tawrakani handarakani haiba de equilibrium se backward direction adi undissociated acetic acid lomdo oina chatkani eba haiba se kari haiba ga managi haiba matamda hydrogen ion gi concentration handara haidana to wahi amada haira suyai karigumba acetate ion hapchalabdi acetic acid solution da ko asmai tawdana hatangna karigumba external source amadagi hydrogen ion do acetic acid solution da hapchalabdi hydrogen ion hapchalasu samanai mamangi adamaina equilibrium se backward direction da move tawgani backward direction move haibadi kaino haiba matam da backward direction haibadi undissociated acetic acid lomdani undissociated acetic acid lomda move tawba haibadi acetic acid se masigi dissociation handara e haibani suppress tawra e haibani haidi basisu amuk hydrogen ion hapchalabani na concentration external source tagi hapchalabani na acetate ion gi concentration handara e haibaga topo wahai amada manayeba aduna mathakta piriba se common ion effect ki example amani masigi common ion effect sina thonba phenomenon gi example amani ko aduna phenomenon common ion effect ki phenomenon se masi Lee-Salier's principle haidna ikone tamkiba mamangna tamkiba adugi aduda base tawba phenomenon amakhakne gyan ko. Next is solubility. Solubility of a solute in a solvent at a particular temperature is defined as the amount of solute in grams that can be dissolved in 100 grams of a solvent to form a saturated solution at that temperature. Okay. What are the factors affecting solubility? Solubility of a solute in a solvent depends on the following factor. It depends on the nature of the solvent. It also depends on the nature of the solute. It depends on the temperature, and also it depends on the pressure. Effect of pressure on the solubility is very small in case of solid and liquids, okay, but the effect of pressure on the solubility is more in case of gases, okay. The last one is solubility product of a salt. Solubility product of a salt at a given temperature is equal to the product of its ionic concentrations in a saturated solution, where the concentration terms are raised to the power equal to the number of ions produced on dissociation of 1 mole of the salt. Mathematically, in general, let us consider a sparingly soluble salt having chemical formula AXBY. AXBY is a general formula for sparingly soluble salt. Okay, let us consider this sparingly soluble salt. If this sparingly soluble salt is dissociated, means it dissolves in water, it dissociates very little into its ion. Okay, so it maintains equilibrium between its undissociated salt and its ions. Here, AXBY, this sparingly soluble salt dissociates into ion S, X number of AY positive and Y number of BX negative. AY positive and BY negative are the ions in solution which are formed after dissociation of sparingly soluble salt AXBY. Okay. Now, the solubility product of this salt AXBY is represented by KSP, okay, which is equal to concentration of AY plus power X into concentration of BX negative power Y. Okay. Now, let me explain you in Manipuri also. Aikoy hojik solubility product IC karino tamsi. Aroy boy na ko ngasigi class gi aroy boy na aduna sol amage apiba temperature given temperature amada salt gi solubility product hai basic karino hai matamda haiba salt gi apiba temperature amada solubility product hai basi salt na dissociate tora kanta kaitharak liba ion sing do madugi concentration tam sing do maduda ion masing do na power kasel laga multiply to budagi phangakpa result of salt to product to aduga manayaba aduna aikoi hena clear oinaba mathematical expression si yengo sparingly soluble salt ama khanarasi sparingly soluble salt haidi isingda yamna tumgandaba yam wana tumba salt ama khanarasi hariba sparingly soluble salt to ge magi general formula si AXBY ne na aikoi lorasi AXBY leiba sparingly soluble salt se masi ising da yam tumgandabni na ma ising da solution semabdi masi magi ion x number of ay positive and y number of bx negative haidna cation anion thongna kaitharakani mana kaitharakli ba cation anion se masiga dissociation tawdaba kaithadaba solution du da yauriba axby duga anisigi marakta equilibrium maintain tawgani karigino haiba matamda sparingly soluble salt oibanina yam wana kaidhabanina kaidhadaba kharasu yaugani ba aduna kaidhadaba undissociated salt tuga kaithakhraba cation anion singdo maduga anidugi marakta equilibrium maintain tong leini ba aduna hariba axby general formula laiba sparingly soluble salt sigi solubility product karino haiba matamda masi solubility product si ksp haidana masina mahut sille masi kanaga mana gai kanta solubility product haibni product adi multiply haibni dana aduna multiply tawna doine ba kana multiply tawna doino haiba matamda hariba sparingly soluble salt se kaitharak la kanta semi ba magi cation anion do cation di kanano ay positive anion di kanano bx negative aduna cation ay positive ki concentration gi tam du da cation masing x no power kasalaba masiga anion bx negative sigi concentration siga masigi concentration tam sida anion masing y na power kasalaba ani sigi multiply tawbagi result to ga managani haiba yan tare ko